Assalamualaikum and hello everyone. Welcome to a new video for a new chapter, Chapter 6, Chemical Equilibrium. Where in this video, we're going to learn 6.1, Dynamic Equilibrium. Okay, in this subtopic, the learning outcome is explain the term reversible reaction, dynamic equilibrium, law of mass action. Then state the characteristic of a system in equilibrium. And last but not least, interpret the curve of concentration, reactants, and product. Okay, so we have learned about the chemical reaction, and so far what we have learned is actually an irreversible reaction. Irreversible reaction ni sama juga dengan non-reversible reaction. Okay, so what does it mean? Okay, remember for a reaction, so we have this arrow kan, and then for the left hand side, we call it as our reactant, and our right hand side, we call it as our product. Okay, so for example, this is a reaction CH4 with O2. So it means that our CH4 ni undergo combustion and it will form the product is CO2 and H2O. Okay, so for the irreversible reaction, the reaction takes place in one direction. Okay, so kenapa in one direction? Reaction ni only occur from the reactant to form product kita. So contohnya kita dekat sini, kat sini is actually our combustion kan. Sama jugalah dengan our titration from our acid and base. Dia akan it will react to form our salt and water. Tak ada reaction yang salt and water tu yang jadi acid and base kan. Okay, and then for the irreversible reaction is that the chemical reaction will proceed to completion. Okay, so the reaction will continue until one of the reactants is completely used up and the reaction stops. We have learned in chapter 1 about the limiting reactant, excess reactant. Okay, so kat sini ada bagi tahu. Again, the reaction continue until one of the reactant is completely used up. Okay, so once the limiting reactant is completely used up, so it means that we do not have any lagi reactant kan. One of the reactant tu is finished. So even though, for example, O2 ni excess reactant kita, even though we do have plenty of O2 left, tapi for the reaction to proceed, kita kena perlukan dua-dua reactant kan? Okay, so because one of it is finished, so reaction will stop. So dia kata, and the reaction stops. Okay, so that is for irreversible reaction. Okay, so the new thing that we are going to learn in this chapter and forward, we're going to learn about reversible reaction. So again, so we have our A and B to become C. Remember that left hand side is our reactant and our right hand side is our product. Okay. So dekat sini it is a reversible reaction. So dia kata dekat sini the reaction proceeding from left to right. Left to right tu it means that from our reactant to our product. So this is actually what we call as forward reaction. Okay, and then the reaction proceeding from right to left. So right to left ni is actually from product to our reactant. This is what we call as reverse reaction. Okay, and the chemical reaction which take place in both forward and reverse direction are called reversible reaction. So contohnya I'm just gonna write down kat tepi ni. Remember that forward, kalau forward reaction must be from the reactant to product. Kalau reverse, yang terbalik, it's actually product to reactant. Okay, so yang sebelum ni kita yang selalu belajar ni, it's actually from reactant to product sahaja kan. So, all the reaction that we have learned is actually from our reactant to product, which is a forward reaction. Jadi sekarang ni kita akan belajar reversible reaction, where not only the reactant can combine to form product, but the product can also dissociate to form our reactant. Okay, and then for the reversible reaction is that we're going to use this arrow. Arrow yang macam ni It's not this kind of arrow, bukan yang macam ni. And bukan juga macam ni. It must be this arrow lah. Okay, so that is actually an introduction to what is a reversible reaction. Okay, now we're going to interpret the curve. So for a given reaction, we have A equal to B. So again, A ni is actually ini kita punya reactant. Just gonna reactant, B ni product lah. Okay, so consider the following reaction. Okay, at the start of reaction, kita tengok concentration of A ni Kita nampak dia punya arrow dia macam ni kan. Sebenarnya, concentration of A, dia decrease with time. Dia makin berkurang. Okay, why? Sebab reactant ni, once the reaction proceed, reactant ni akan form produk kita lah. So, that's why the concentration will decrease with time. Kalau yang A. Concentration of A decrease with time. So, the rate of forward reaction, it will increase. Maknanya sebab dah reactant ni jadi produk kan. So, they increase. Okay, so that is for our A. So, sekarang kita tengok B pula. Okay, so B ni dia start pada 0 sebab remember at the start of reaction, produk tak form lagi tau. So, sekarang ni, so for case of B, kita tengok as time proceed, kita punya concentration increase. Okay, so, the rate of reverse reaction pun akan increase. At one point, the rate of forward and reverse reaction becomes equal. So, what does it mean equal ni? Dia kata, sebenarnya, okay, at one point ni kan, after T equal to 1 ni, what would happen that concentration of A dengan B, they remain constant. So, contohlah, kalau dekat sini concentration of A is actually 0.5. Memang contohnya, T yang ni kat sini time dia 20 second kan. Dekat sini contohnya 40 second pun masih lagi concentration dia 0.5. Contoh kalau kita punya B pula, dekat sini kita buatlah concentration dia contohnya 1.5. Okay. So, even though reaction proceed, time tu increase, dia punya concentration dia sama sahaja. That is meant by yang one straight line ni lah. So, here it mentioned that concentration of A and B will remain constant, but it is not equal. And at this point, the system is said to be in equilibrium. Okay, equilibrium ni, in layman's word, dia is actually balance lah. Okay, ataupun kalau kita tengok balik definition dia dekat sini. Equilibrium is a state in which there are no observable changes as time goes by. Okay, ataupun dynamic equilibrium. Okay, yang ini yang kita belajar the linear outcome. What is dynamic equilibrium? Specifically, here is that the reactant and product concentration stop changing because the forward and reverse rates have become equal. So that is actually, sebenarnya kita kata sekarang ni this system is in dynamic equilibrium. Sebab dia punya concentration dah stop changing. Okay, why dia stop changing? Sebab the forward and reverse rate have become equal. Next we're going to look at what is meant by in equilibrium tu lah. What is the characteristic of a system in equilibrium? Equilibrium can only occur in a closed system. Closed system tu maksud dia, contohnya kalau kita ada container kita, okay, so we have two of our container. Kalau closed system tu maksud dia is being closed lah, maknanya memang tutup. Kalau open tu maksudnya our container tu is open lah, tak ada penutup dia. Itu sajalah. Okay, what is the characteristic? Okay, the characteristic is the concentration of the reactant of the product and reactant and products are constant over time, and then the forward reaction rate equal to reverse reaction rate, and last but not least is the reaction quotient Q is equal to the equilibrium constant. Okay, so yang nanti ni kita akan tengok in detail lagi in 6.2 where we're going to calculate. Nak tahu betul tak is actually in equilibrium ke tidak, so we have to calculate the Q, the value of Q2. Okay, so that is the characteristic. Okay, last but not least, we're going to look at is the law of mass action, which is the other name for it is equilibrium law. So it mentioned here at a given temperature, a chemical system reaches a state in which particular ratio of reactant and product concentration has a constant value. So maknanya from this reaction nanti we're going to form a constant value. We're going to denote it as K. So K ni is actually a ratio of reactant and product concentration. So for a given equation, yang ni a general one. So kita kata akan reach a constant value. I'm going to give it as K. Okay, it will be the concentration, the ratio kan. But it's actually the ratio of product over the reactant. So dalam case ni, this is actually our species, the capital letters ni. The small letter is the coefficient. So how we're going to write it down? The constant will be product over reactant. So product di dalam case ni is actually C. Okay. Sebab dia kata dekat sini, concentration. So, kalau concentration tu, our symbol is actually square bracket. Dia tak boleh guna round bracket ni, tak boleh lah. It must be a square bracket to denote that it is about our concentration. So, concentration of C, so species kita C ni is actually coefficient. Coefficient ni akan jadi to the power of. Okay, and then product kita ada juga D kan? So, we have to do for D as well. Okay, so we have written down for the product. We're going to divide by our reactant. So, reactant ni is actually A dengan B. So, sama juga. Our species is actually A. Small a is the coefficient. And then, ada lagi satu B to the power of B. Okay, so where K is actually our equilibrium constant. And ni, we will calculate it in 6.2 lah. How to calculate semua tu kita akan tengok. Okay, so untuk this is actually for a general equation. So kita tengok specific equation lagi. So this is actually reaction between hydrogen and iodine to form hydrogen iodide. Okay, so maknanya again K ni ratio of product over reactant kan. So K is equal to our product. Again the concentration. So it must be a power bracket. Okay, produk kita sebenarnya HI. Okay, hydrogen iodide ni. Okay. But then, we do have this value kan. This is actually our coefficient. Coefficient ni akan jadi to the power of 2. So, kat sini to the power of 2. Okay, divide by our reactant. Reactant kita is our hydrogen gas dengan iodine gas. So, again, sebab concentration, square bracket, H2. And then, actually, dekat sini, if we do not have any value in front of this species itself, so it means that there are 1 lah kan. So, kalau kat sini, tak perlu pun tulis the power of 1. Nak tulis pun boleh, tak nak tulis pun it's fine. Okay, H2 we have written down. Next is I2. So, we're going to write down I2. Okay, so that is actually the how to write down for the equilibrium constant for this reaction. Again, K is our equilibrium constant. Last but not least, we're going to look at for the formation of ammonia. We're going to react our nitrogen gas dengan hydrogen gas. So, how we're going to write down our K? First is actually ratio of the product over reactant. So, our product is actually NH3. It will be to the power of the coefficient kita. Coefficient kita is 2. 2. Okay, divide by our reactant. So, reactant kita dalam kes ni we have 2 kan? Nitrogen dengan hydrogen. So, dekat sini N2 gas. And then, kita ada, remember N2 gas ni sebab sini 1 kan? So, I did not include lah. Tapi dekat sini, H2 gas ni, sini kita ada 3 kan? In front of the species tu, kita buatlah to the power of 3. So, again, K is actually our equilibrium constant. So, that's it for 6.1. Okay, memang 6.1 ni is very short subtopic lah. Hanya satu page ni sahaja.